Okay, you guys, I wanted to practice with you guys a little bit on atomic structure and kind of re-emphasize what isotopes are. So from the video lecture, and hopefully the study.com video as well over isotopes, you've kind of got the idea. So atoms have several different kind of versions of themselves, if you want to think of it like that. So all atoms have two or more what we call isotopes. And what makes them different from one another is strictly the number of neutrons in the nucleus, as well as their atomic mass or their atomic weight. So for instance, and I've used this as an example before, boron has more than one isotope. Boron, you can have boron 11, or you can have boron 12. Change that. That would be boron 10. Okay, these are two isotopes of boron. Several different ways you can write isotopes. This is one. This gives you the element's name, and this number, this whole number right here is the mass number. And a quick reminder, the mass number is the sum of the protons plus the neutrons in the nucleus. Okay. How this links up to what we talked about on the periodic table is this. Whichever isotope is most abundant in nature, as in you find it most often in nature, is going to be the one that is found on the periodic table of elements. So if I was to look over here, I find boron, and I look at the atomic weight. The atomic weight is 10 point, see if I can focus that better. There we go. The atomic weight is 10.811. So 10.811. If you guys remember that if we round that to the nearest whole number, that is going to give us the mass number. However, in nature, there's more than one isotope of boron. There's boron 11 and there's boron 10. Okay, the one that we represent on the periodic table is boron 11, and that's because it is the most abundant in nature, as in if we are to gather up all of the boron atoms out there, most of them would have the mass number of 11, or would have the atomic mass of 10.811, which would round to 11. Not all of them, but most of them. So if we are calculating the neutrons of each of these, what we are going to do is we are going to take our mass number, and we are going to subtract the atomic number, or the number of protons, which would be 5. So on boron 11, we would have 6 neutrons. On boron 10, boron 10, if we subtract the atomic number, we're going to have 5 neutrons. So the only thing that is different between boron 11 and boron 10 is their number of neutrons. Okay, this guy is represented on the periodic table because he is most abundant in nature. He's still in nature, just we don't find him that often. Okay, with that, I want to look at the atomic structure practice that was on one of the last slides of the PowerPoint. And I just want to work you guys through this. You need your periodic table. You have several assignments that you'll be doing this exact thing. So I'm going to try and kind of zoom out a little bit, and maybe you can see this a little bit better. I'm not sure if I can do this. Okay, so oh, I did want to tell you one other, or explain one other thing, sorry, before we get started. What I do want to look at is a way to write the isotope symbol. So this is one way to represent the isotope, the name and the mass number attached to it. Another way to represent the isotope is using its symbol. So this is an isotope symbol. So it would look like this. I take the elemental symbol, I take the mass number, and it goes right on the top. So I'm going to put 11 here, and then I'm going to put my atomic number right down here. Okay, so this is considered to be the isotope symbol for boron 11. And we usually name isotopes by their mass number, so boron 11. Or I might have carbon 12. This would be an isotope symbol. This number is the mass number. This number is the atomic number. Okay, now let's get started and let's do a little bit of practice. So the first thing on these assignments and on this example, your mass number is either going to be given to you or you are going to have to figure out the mass number by adding the protons and the neutrons together. You're never actually going to go to the periodic table and round the atomic weight to the nearest whole number. Not on these worksheets, because we're going to be dealing with several isotopes of the same atom. Okay, so let's start with the very first one. So the first one is atomic number 80. So I'm going to look on my periodic table and I am going to find the element with the atomic number 80, and it's right here. That is mercury. So I am going to name it mercury. And then I'm always going to attach here my mass number, which is 198, which is given to me. Number of protons is the same as the atomic number. If I know the protons, I automatically know the number of electrons because they're always equal. So I'm going to put 80 right there. I'm actually going to have to calculate the number of neutrons. To do that, I'm going to have to take the mass number, which is 198, and I'm going to have to subtract the atomic number, which is 80. So that would be 8, 1, I think it's 118 if I'm correct. But let's double check because I'm bad with math in my head. Is equal 118. I'm correct. So I'm going to add my 118 right here, and then I'm going to write my isotope symbol. So the symbol for mercury is Hg. I'm going to put my mass number right towards the top of my symbol, and at the bottom of my symbol is going to go my atomic number, which is 80. So let's do the next one. So atomic number, they tell us that I'm dealing with the isotope calcium-42. So I'm going to have to go to my periodic table to find the atomic number. So you're going to look over here. Atomic number for calcium is 20. So I'm going to write 20. If I know that the atomic number is 20, I also know the number of protons is 20. If I know the number of protons, I automatically know the number of electrons. So I'm just going to fill that in. And now what I'm going to do is I'm going to calculate the number of neutrons. So I'm going to take my mass number, which they give me, so 42, and I'm going to subtract my atomic number, which is 20. That will give me 22 neutrons. 22. And then my mass number, they give it to me, so I just have to copy that over. And then my isotope symbol, I'm going to put Ca. My mass number goes at the top, okay? And my atomic number, which is right here, goes on the bottom. Let's do the next two. Okay, so atomic number is 26. So I'm going to go to my periodic table of elements, and I am going to find atomic number 26, and that is iron. So iron. I'm just going to put a dash here because it does not look like it has given me my mass number, so I'm actually going to have to calculate it. Atomic number 26, oh, they already gave me, good. Number of protons would then be 26. Number of electrons is going to be 26 because the electrons always equal the protons. We're going to calculate the mass number here. We're going to have to take the number of protons and add it to the number of neutrons to get my mass number. So I'm going to take 26 and I'm going to add it to 31. That will give me 7 and 5. So my mass number in this case is 57. So now I can attach it to my name and I can do my isotope symbol, which is Fe. There we go, which is Fe. And my mass number we decided was 57. And my atomic number is 26. So if we look at the very last one, atomic number 19. So I'm going to go to my periodic table, atomic number 19, and that's potassium. And I see that they already give me my mass number right over here, so I'm just going to attach it to the name. Atomic number is 19, so that means I have 19 protons. I'm going to leave the neutrons to the end because I'm going to have to calculate it. The number of protons always equals the number of electrons. So now let's calculate the number of neutrons. So I'm going to take my mass number and I'm going to subtract my atomic number, and that will give me my number of neutrons. So that is going to give me 22 neutrons. And then for my symbol, K, the mass number goes right up here is 41, and my atomic number goes right here. Okay, you guys, I hope that was helpful. I'll be honest, I can't remember from my first video if I went through that or not, but I just wanted to cover all my bases and make sure you guys don't have any questions. Hope you're all well. Take care of yourselves, and I will talk to you guys soon. Bye-bye.